Hi all, welcome to JJ Coders. In today's video, let's see what are all the unary operators in C and how to use them with an example program. Unary operators can perform an action with single operand, where binary operators need two operands. To understand this, let's see an example. In the first example, we can see in C equal to A divided by B. Here, the divide operator is the binary operator. It needs two operands A and B to perform the divide operation. In the second example, there is int A equal to 5 and then A with increment operator. Here, the increment operator is an unary operator. It only needs A to perform the action. It increments the value of A by 1. I hope you can understand what is unary operator now. Now let's see the list of unary operators in C. The first one is the increment operator. It increments the value of a variable by 1. The second one is the decrement operator. It decrements the value of a variable by 1. The third one is the unary plus operator. It can convert a negative value into a positive value. The fourth one is the unary minus operator. It can convert a positive value into a negative value. The fifth one is the logical not operator. It inverts the result of the condition. The sixth one is the bitwise not operator. It reverses the binary value of the variable. The seventh one is the address of operator. It is used to store the value into the variable. We have used it while learning about the scanf. If you have not watched that video, please check our playlist. The eighth one is the indirection operator. It is used to access a value of the variable using its address. The ninth one is the sizeof operator. It returns the size of the data in bytes. The 10th one is the typecast operator. It converts the value of variable from one data type to another data type. Now let's see this with an example. Let me open the VS Code and create a C program named unary.c. I am including the header file stdio.h as I am going to use printf. Then I am creating the main function of the program. Now I am declaring an integer variable a and I am assigning a value 5 to it. And in the next line, I am just printing the value of a using the printf function. At the end of the main function, I am adding the return 0. Let's save the program using the Ctrl S. And in the terminal, type gcc space unary.c and then press enter to compile the program. Once the compilation is done, type ./a.exe to run the program. We can see the output a equal to 5 is displayed. Now I am adding the new line in the program, a increment operator. Increment the value of a by 1. Let us check the output now. In the output, a equal to 6 is displayed. This means the value of a is incremented by 1. Let's change the increment operator into the decrement operator. This will decrement the value of a by 1. And from the output, we can see a equal to 4 is displayed. Now let's try using unary plus operator. Let me declare another integer variable b and I'm assigning 6 as the value. In the next line, I'm assigning plus a to b. This means the positive value of a stored to b. And I am updating the printf to print the value of b. Now the output displayed as b equal to 5. Now let's change the statement with the unary minus operator. This stores the negative value of a into b. Again, let's check the output. We can see b equal to minus 5 is displayed. Next, we can try using logical not operator. To do so, let me declare another integer variable c. I am assigning a condition b is greater than a to c. So c will get 1 if the condition is true. We have seen this in our relational operator video. Now let's try printing the value of c in the output. We can see c equal to 1 because the condition is true. Now let me add the logical not operator to the condition. Now c will get the opposite value from the condition result. In the output, we can see c equal to 0 is displayed because the opposite of 1 is 0 stored in c because of the logical not operator. Next, let's check the bitwise not operator. I will remove the variable c and I am assigning bitwise not of a to b. For every value in the variable, there is a binary representation. This bitwise not operator will reverse the binary representation of the value in the variable. I will update the printf to display the value of b. Let us check the output now. In the output, we can see b equal to minus 6 is displayed. It is the binary reverse of value 5. Next, let's use the address of operator. As I said before, we have used it already with the scanf in our previous programs. Usually, every variable in the program has a name, an address, and a storage location. For example, int a equal to 5 is the variable we declared. In that, int is a data type of the variable. A is the name of the variable. The variable a will have a storage location in the memory. That location is referred by a address. In program, when we call a, it's the value of a. When we call address of a, it's the reference location of the value in a. Now let's try printing the address of b in the printf. We can see the reference value of b displayed in the output. Now let's use indirection operator. We can also call it as pointer. You can declare a variable as the pointer using this indirection operator. Unlike usual variables, a pointer can store address of the another variable. I will change a variable b into a pointer variable and I am assigning address of a to pointer b. Now the b stores the address of a. Using this address, b can access the value of a. Let me print the value of pointer b in the printf. We can see b equal to 5 is displayed, where 5 is the value of a. So b accessed the value of a using the address of a. So in this video, we saw about unary operators. Please like this video. Also, please subscribe if you are new to this channel. Thanks for watching.